Okay, so section 8.7 is still factoring, but there's those special cases. So if you remember, we had problems like x plus 3 quantity squared, and you had to multiply those out. And then also remember we had the x minus 3, x plus 3, and it ended up looking like this for a difference of two squares. And then this one up here ended up looking like that. So we're going to do the reverse. So you're going to be given this and have to go there, or given this and have to go to that one. So here's my first problem. I have x squared minus 12x plus 36. You're not going to do anything different. You're going to end up looking for the same thing. So my first step, look for greatest common factor. Greatest common factor is 1, so I don't have to do that step. So then I slide this 1 over and have 36. So I need factors of 36 that add or subtract to negative 12. So I would use negative 6 and negative 6. So here would be my two sets of factors. I come back and I divide by the number I slid, which was 1, so I end up having still the same thing. The only difference is you will need to write it with an exponent since you do have two of the same thing, so I would simplify it and take it to that last step. Pause the video and see if you can do the next one. So on the next one, you are given x squared minus 14x plus 49, so I look for my greatest common factor, which is 1. I slide over my 1 that's in front. I still have 49 and negative 14, so I use negative 7 and negative 7. So I have x minus 7 and x minus 7. I divide by the number I slid and simplify, and then I always rewrite it. So x minus 7 quantity squared. So do make sure that you rewrite it with that exponent. Okay. So now we're switching to the other kind where you have a difference of two squares. So if you have z squared minus 9. So you can still do it the same way. So I can still have it as negative 9 and then my sum. Now the tricky part is there's no middle term, so it automatically is a 0. So I need factors of 9 that add or subtract to 0. So 3 and negative 3 would find that suit. So then I would write out my factors, come back and divide by the number I slid, which is 1, and it's still being z minus 3 and z plus 3. So the shortcut is if you know that you have a difference of two squares, which means a square is 1 is a square, 4 is a square, 9 is a square, 16 is a square, 25 is a square, 36, etc. So if you can find that these numbers are squares, it always will fall suit into this. So you can do the square root at the beginning, square root at the end, and then just put a plus and minus in between them. Okay, so on the next question, it's still the same thing, but notice that now our numbers are a little bit bigger. So you may not want to slide this over. Instead, you may want to use the shortcut like you and I were discussing just a second ago. The shortcut being that if every time I have two terms and these numbers are squares, I can write it in this form. Well, 16 is a square, meaning if I did the square root, it'd be a whole number. 81 is a square, meaning if I did the square root, it'd be in a whole number. So I can write it in this form. The square root of 16 would be 4, so I'd put 4x and 4x at the beginning. Square root of 81 is 9, put 9 and 9 at the end, and then since it's negative, I want a sign of each so that it times to negative. This might be a lot faster than you trying to slide it over because 81 times 16 would be a very large number to use. So when you have two terms, I would encourage you to use that shortcut instead. Alright, pause the video and see if you can do the got it question. So in the got it question, notice that you have two terms again, and 25 is a square, 64 is a square. So you should be doing the square roots of them and getting 5d at the front, 8 in the back, and then putting in a positive and a negative in between them. Alright, so last problem is just putting all the pieces together. So remember that your first step always is looking for a greatest common factor. So is there a number I can divide 24 and 6 by? Yes, 6. So I'm going to take that 6 out first. Then notice that I have two terms left. 4 is a square and 1 is a square. So my 6 is going to stay put out in front, and then I'm going to factor this like we have been. So the square root of 4 is 2, so I'd write 2g at the beginning. Square root of 1 is 1, so I'd put 1 and 1, and then put a sign of each. Pause the video and see if you can do the last got it question. Okay, so in part A, I would see if there's a greatest common factor, which there is, 12, so I would divide both of those by 12 first, and I would get t squared minus 4. There is a 1 in front of there, so if that bothers you not knowing if that's a square, you can put that 1 there. 1 is a square, 4 is a square. So 12 is going to stay out in front. I'm going to do the square root of 1, which is 1t and t, do the square root of 4, which is 2 and 2, and then put 1 of each sign in there. Okay, last one. Again, I look for a greatest common factor, which is 3, so I'm going to divide all of those by 3, and I get 4x squared plus 4x plus 1. Then we're going to keep that 3 out there, slide this 4 over with the 1, and then I need factors of 4 that add or subtract to 4, which are 2 and 2. So then I end up factoring as 3 still out in front, x plus 2 and x plus 2. I need to come back and divide by the number I slid, which is 4 and 4. That reduces on both of them to 1/2, and so then I need to bottoms up on both of those spots. So I would have 3 times 2x plus 1 times 2x plus 1. Notice I have the same factor written twice, so I need to rewrite that with an exponent. So my final answer would say 3 times the quantity 2x plus 1 quantity squared. Okay, that's it for all of the factoring. So after you've done this lesson, then you're done with factoring for a while.